Hello. So today we're gonna start Chem. Okay. Yeah, we're gonna do organic chemistry first. And we're just gonna start doing questions. It's not that. Organic chemistry is actually not as hard as I thought. Cause it's just like a bit of memorizing and that's it. Okay, yeah, so first we'll name two, let's say. Here's the first question. So we want to name this thing. All right, so there's only two carbons, so it's definitely a ethene, yeah. So it's ethene at the end. Then there's it should be okay. So then because is it's trans, yeah, because it's on different sides instead of on the same sides as cis. So it's trans, and it's be one two, yeah, it'll be 1 2 dibromo ethene, because ethene can only have the double bond in the middle, so we don't have to write one ene, two ene. Okay, yeah. I'm gonna do a second one, and it's like this: H2HCH3. This one have a CH3. This one have a CH3. Okay, so the longest chain we'll find is 1 2 3 4 5 6. So it's a hex 2-ene, and this is a cis. So it's cis 1 2 3 4 5 methyl hexane. Yeah, that's it. But then we do have to write it together because that's the waste, how Australian waste works. Yeah. So that's the name. Now we'll do a question on drawing it. So here's 1 dichloro cis but 2-ene. Okay, so it's but, so there's 4, so C. There's no cis. They put cis in the middle, but I think the thing nowadays is you put at the front. Yeah, so 1 2 3 4 cis. So we're gonna put these down here, and it's 1 dichlor, right? So we can put the chlorines here, and we can have another hydrogen. So there's 4, and then that's a hydrogen. That's a hydrogen. Hydrogen. Yep, that's it for this one. And 4 5 ethyl hept 1-ene. Okay, so because it's hept, there's 7. 3 4 5 6 7. 1 2 3 4 5. That's eth. That's it. I'm gonna do the hydrogens. It's actually the best to draw the hydrogens in the test, although it takes a lot of time. They can't take Markov, because if you write in the other way, they might not accept it. And make sure each one only have 4. Yep, that's it. And let's do which question? 5. Petroleum contains many substances and that have the same formula but different structures. Draw the structural isomers and write systematic names of all isomers. This is gonna take a long time. Okay, let's do it first. So pentane, right? What isomers? Structural isomers. So they have the same formula but different structures. So pentane is just 1 2 3 4 5. C5, H12, yeah. So then all isomers. That's a lot. Okay, yeah. So first we'll do the normal one. Because it's a lot, I'm not even I can't do the normal. Oh, you know what? I'll do it. 3, 4, 5. Okay. Now 4 chains. Uh Fifth one have to be here, and if you rotate, so this is the only one that's 4. Because if you put it anywhere else, it's the same structure, but just orientate differently. So that's it for 4, and for 3. 1, 2, 3, 4, 5, and that should be the only one, and that should be it for the ains. And now we can start drawing the, let's number these. And 4, we can draw a 1, 2, 3, 4, 5. H. That's a cyclopentane. Actually, the cyclos don't have the same amount of hydrogen, so you can't draw this. But we can draw the ethene, the enes, alkenes. Yeah. So wait, can we draw the alkenes? Actually, because it's a pentane, you can't have the alkenes at all, because that just means there's 2 less hydrogens. So that's it. The 3. That should be it. Yeah, that's it for these ones. Yeah. Okay. I thought it was shorter than I thought. Okay. B. Now it's pentene. Pentene can have a lot. First, let's do the normal ones. Um, this one can't have geometric isomers like cis trans, because it looks the same anyways. And that's 1 and 2. We'll have it in the middle. Yeah, this one can have cis trans. Yep, and we'll have 1, 2, 3. We should have drawn at the front, but no one cares, so hydrogen, hydrogen. That's the trans one. And now that's it for the 5s. Now we can do the 4s. Actually, let's do the easy ones first. Yeah. This one can't have cis trans either. This one can. That look like an E. Okay. Okay, that's it for the 4s. Let's see if the 3s are possible. Yes, it is, and there's can only be 1 still. Because if we have 2, it wouldn't work. Yeah, that'll be the same as this one. Okay, that's that. Actually, is this possible? There's 5 bonds. Yeah, No, it's because we're missing a bond from these ones. So we can technically have it here, or we can have it here. And there's no threes because there's not enough bonds. Okay, yeah, we'll do that. So it's exactly this one. Yep, it's exactly this one, but instead of the carbon here, the carbon goes here. Can the carbon go on the first one? No, that'll become this one. No, that'll become the five ones, yeah. Yeah, this one can fit another one, and for this, yeah, and 8. We can have these two can have different ones as well, but they do have to be in the middle. So that's not that bad. It's just one of these became one of the hydrogens become a carbon. That's it for the alkenes. Now we can start drawing the cyclos. So yeah, that should be the same as an alkene because the cyclos are missing 2 hydrogens as well. And 9. C. All right, and 10. 10, we can have a 3 cyclo, yeah? So hydrogen, carbon, carbon, or we can have a triangle cyclo with a C and another C, ethane on the end. All right, now we can do question. It should be 6 now. 6. 4 isomers of C4H9Br. This is technically a alkane. It does not have to be alkane. So first we'll have 1, 2, 3, 4. Because these add to 10. So C4H10 have to be alkane. The enes, the cyclos, all can't be this. So we'll put the Br here first. And we can put the Br on this one. It'll be different, but the rest should be the same. So there's only 2 isomers for the 4 carbon chains, because if I put the Br here, it'll look the same as this one, because you just have to flip it. And if you put it on the other side, it'll be the same as well. No, it's because the bonds are rotatable, unlike the alkenes. And then a third one have to have 3 carbons, yeah? And the middle carbon have to be here. So let's put the Br here first. And because they're all out of here, we can literally put the BR here, and they'll be the exact same as this one. Because the C's are technically like, they all look the same, so you can flip and look the same. So this next C have to be right here. Yeah. So a 4th, which is our last one. I think there's no more. Pretty sure there's no more. Have to be here. That's it for the questions on organic chemistry today. All right. Bye bye.